This is chapter 18, exercise 30. The topic here is estimating sample size. And most of the time, you're told the sample size. You're told, out of a sample of 500 people, blah blah blah, and then you're told to figure out the margin of error and so on and so forth. However, these questions it turns it around where they give you a desired margin of error and a desired confidence level, and then you got to figure out what the sample size should be. So let's take a look at this. Number 30, it says, it's believed that as many as 25% of adults over 50 never graduated from high school. We wish to see if this percentage is the same among 25-year-old to 30-year-old age group. So part A, how many of this younger age group must we survey in order to estimate the proportion of non-grads to be within 6% with 90% confidence? Okay, so before we start this question, let's just do a quick review of the basic confidence interval formula for a categorical variable. So you start with your point estimate, the result from the sample, p hat, plus or minus your critical z-score, which depends on your confidence level, times your standard error, which is square root p hat q hat divided by n. All right, so on this basic formula, we're just looking at this part. And this, the z critical z times the standard error, that's your margin of error. So you don't need p hat for these, so we can erase it here. And we just look at the margin of error. So we just call this equal to m. All right. So that's the formula you can use to figure out these these sample size questions. So m is the desired margin of error. And on these questions, that will be given to you. Now, p hat, now, of course, you don't know exactly what p hat is because you need a sample to take p hat, but you can't get a sample until you know how big your sample is going to be. And so p hat is, it's a guess. It's a guess about the proportion of successes, or maybe I should say of a guess of the proportion of successes in the sample. And often in these questions, there'll be some kind of clue to help you take a guess. In this case, it says 25% of adults over 50 never graduated. And so that's like your starting point. You can say that that's a reasonable guess. Now, if you have no idea at all, then you just let p hat be 0.50, 50%. Okay, and then of course q hat is just 1 minus p hat. So if you think 25% of people have not graduated from high school, then 75% have. And then z star is your critical z, which depends on your confidence level. And, or I should say the desired confidence level. And usually on these questions, it'll tell you, like for example, on part A, on this question, it says 90% confidence. All right, so just to refresh your memory, for 90% confidence, the z is 1.645. 95% confidence, z is 1.96. For 99% confidence, z is 2.576. For any other confidence level, like if they ask for like 98% confidence, then or something like that, then just go to that normal curve website and figure it out. All right. So step one is to figure out what is m, p hat, and so on and so forth. So and then you plug them in. So plug in the numbers. Okay, and then once you've done that, then you have to solve for n. And then step 3 is then you round up. Because usually the answer is a fraction, but you can't have like, 7.5 people in your sample. It has to be a whole number. And you always want to round up, because if you round down, then you won't quite get enough of your margin of error won't quite be big enough. So you always round up. Okay, so let's work this one out. So it says here 25% of adults didn't graduate from high school, so we'll just use that for the p-hats. Now you could say, well, probably younger people, the percentage is lower. You could take an educated guess, but we'll just use p-hat 25%, q-hat 75%, and then 90% confidence. So that's 1.645. And the desired margin of error, it says for part A, it says 6% margin of error. All right, so that's a desired margin of error is 0.06. Always put that in decimal form. So just plug them into the formula, which is right here. So Z star is 1.645. Let me just rewrite it down here for reference. So Z star times square root p hat q hat over n equals m. All right, so actually let's start with m. M is 0.06 equals Z star, which is 1.645 times square root p hat q hat. So 0.25 times 0.75 divided by n. Okay, so that's step one, is plug in all your numbers. Step two, solve for n. All right, let's break this down into sub steps here. So solving for n, the first thing you want to do is you do whatever computations you can. Like, for example, I can multiply the 0.25 times the 0.75. No problem there. And then the second thing you have to do is you start undoing everything. When you are solving, you have to do the opposite thing. And so the opposite of square root is square. The opposite of multiply is divide, and so on. Okay, so let's start with 0.25 times 0.75. So 0.25 times 0.75 equals 0.1875. Okay, divided by n, square root, okay, 1.645. Okay, equals 0.06. Okay, so from this point, you just do everything backwards. So normally you would divide by n, that'd be step one. And then step two would be take the square root. And then step three would be multiply by 1.645. So you do all those steps in reverse in order to solve for n. So step one will be divide by 1.645. And so you can do this. 0.06 divided by 1.645 is equal to square root 0.1875 over n. Okay, so let's do that calculation. Let's get out our calculator. So 0.06 divided by 1.645 is 0.036474, etc., etc. There's a lot more calculations to go. So if you round it off to like 0.04, then you do another calculation and the result's even less accurate, and you do another calculation and the result's even less accurate. So don't round off too much. So maybe keep like 6 digits. So 0.036474 should be good enough. Okay, equals square root 0.1875 over n. Okay, now what's the opposite of square root? Well, that's square. So you square this side, square the other side. So the square and square roots cancel. And you have 0.036474. You square it. So on my calculator, this number is sitting on my calculator screen right now. The unrounded number, it's precise to like 20 digits or something. So just, most calculators have a square button. So just, here it is. Just click the square button. And there it is, 0.00133, etc. So I'll just round it to 0.00133. Probably good enough. And then the square and square root cancel out. So 0.01875 divided by n. Okay, so notice that when you're solving an equation, you're just undoing. You're one step by step. You just undo each operation. Okay, now the opposite of divide by n is multiply by n. So I'd multiply by n, but actually there's a little trick you can do. You can make this 0.00133 over 1. You can cross multiply. Probably remember cross multiplying from like junior high school. Usually you learn about that. So n times 0.00133 is equal to, and then 1 times 0.1875. Okay, and then just divide by 0.00133, and you've got your n. So n is 0.1875 divided by 0.00133. Okay, let's get the calculator out one more time. So 0.1875 divided by 0.00133 equals, all right, 140.977. And so that's step 2. All that is step 2. All that solving. It looks really complicated, but it's just undoing each operation. So let's review. So first you divided by the critical z. You divide by the critical z. Step 2 is you square to get rid of the square root sign. Then step 3 is cross multiply. Step 4 is divide by whatever numbers by the n, and you're done. So 141 when you round up. That's step 3. Okay, so you need 141 people in your sample in order to get a confidence interval that has a 6% margin of error and 90% confidence. All right, now a quick side note to this. In real life, you'd probably want to have like maybe 150 or 160 people, because no matter how careful you are with the research, there's always going to be a few individuals who drop out of the study or refuse to cooperate or whatever. And so so you might need 150 people, so that after people drop out, you still have at least 141. All right, one more quick comment about this, and that is, if you look at that margin of error formula one more time, you can see that because you're dividing by n, the bigger the n, the smaller the margin of error gets. All right, so that's just a basic fact because of your dividing. But we can take it one step further. Because the n is underneath the square root sign, then that means that n has to be 4 times as big in order to get the m to be half as big. And so in other words, you have to quadruple the n in order to have your margin of error. So there's a couple questions in the book. Quadruple the n here. Hold on, let me erase that and make it a little bit more. There we go, because it looks like quadruple n, but there's a space there. So you have to quadruple your sample size in order to cut your margin of error in half. And the basic reason for that is because the square root of 4 equals 2. So it has to be 4 times as big to, in effect, divide this by a 2. And so if, for example, if n is like 100 people, your margin of error probably would be around 10% if you were to work it out. So then you'd have to have 400 people to cut your margin of error in half down to 5. And then you need 4 times as many as that. So 400 times 4, you need about 1,600 to cut your margin of error in half to 2.5%. And so you get a bit of a, what's it called? A diminishing return. So is it really worth it to get 1,600 people in your sample just to get a 2.5 margin of error? Or are you good enough with just 5%? Okay, so that's the basic idea on that one.